All right, cool. We're going to get started here. So my name's Alec. I'm a developer at Square, and today I'm going to be talking about multi-platform persistence. And when I was preparing this talk, what I really wanted to do was put as few hypotheticals as I possibly could into it, which is really hard because the technology we're talking about is Kotlin multi-platform, which is highly experimental, as well as Kotlin Native, which is another thing that's pre-release. And so the amount that I am actually doing in production code is pretty much zero. We're not actually sharing any persistence software with iOS. Instead, what I'm going to be talking about is mostly how we're preparing to do multi-platform, and then I'm going to lean on some more open source already working samples like the droidCon app and SDK search to sort of show how it's working in action. And really, the idea for this talk sort of came up as I was onboarding new engineers onto Square Cache. The way I was doing it was these two separate sessions. One of the sessions was going to be talking about how our data flow works and how we get data from the server and persist it and then eventually propagate it up to the UI. And then the other session would be one where I focus purely on the front end of the app and how we do navigation, transitions, animations, those kind of things. And so the way I'm going to start this talk is I'm actually going to onboard all of us onto the Square Cache ecosystem so that we can then start talking about how writing a platformless app is going to work in Cache. And so this is a sample screen in Cache. It's your activity, and it shows some of like the payments you've made in the past as well as people you've interacted with. The way that we get this information is from the server via protobufs. And so server is going to send us a list of customers and payments, and they're going to give us information that we can use to make the screen. So for example, the photo URL is what we're using here to actually populate those avatars. And then from the payment, we can use something like the amount to populate the actual amount you see on the left there. And you can see this is already relational, right? Like a payment is going to reference a customer. And so it seems pretty obvious right now that we're going to start using a SQL database, something relational to power all of this offline as well. So that's the bottommost part of Cache. It's this protos module. A level up from that is going to be the network module, which is where we actually define the endpoints that we're going to be talking to server with. So we're using retrofit to power this, and we've defined a sample endpoint here to sync entities. And so this is the thing that's going to give us those payments and customers back. We give it a sync entities request, and it gives us back an observable of sync entities response. So we're using RxJava to power this whole thing as well. And those requests and responses are also protos. So when this comes into the Cache app, it's going to be as a dependency from protos onto API. So the API layer needs that dependency on protos in order to work. The next module I want to go into is that actual DB module where we're starting to persist some of this data offline. Not all of it is coming from the server, and this is important and why we actually need like a layer that isn't protos. So for example, the contacts and aliases are items that are actually coming from the Android address book, and we need that information alongside stuff we're getting from the server like the customer, so that let's say if someone doesn't have an avatar with Cache, we can instead lean on the Android address book to provide for us an avatar that we can use in this activity. And so we're sort of combining those two pieces of data via some sort of SQL query, and then that's how we're ending up with this UI. So that's another module inside of Cache, this DB module. What's important here is that the API and DB module aren't actually interacting with each other. Instead, there's another layer above that, the backend module, which is going to sort of do the delegation between them. So this layer, it's going to make a request through the API module, get data back, and then persist it using the DB module. So it's the one sort of like dealing with the two of them instead of them working directly with each other. A level up from this is going to be presentation, so the presenters module. Presenters are essentially this paradigm where you're doing all of your business work for UI separate from the actual UI itself. And the way this happens is it exposes view models to the UI and then consumes view events. So it's dealing entirely in this UI-less world, but it's still dealing kind of with the UI, or at least view models, the things that are going to be used to make the UI. Again, this is all observable, so it's emitting observables of view events, and then it's going to be emitting view models and then consuming view events. And that's going to be up to the app module. And I've made it a square here so we know this is the root. This is going to be the actual application that's going to be running. So to showcase how this all works, I'm going to run through like a bit of sample code and how each different module is going to run code just to do one simple action. So we're going to start by creating this activity presenter. And this creation is going to happen when you go to this screen, when it gets attached to the window. As part of this process, when the presenter is initialized, it's going to trigger a sync. And so that's what's happening here. And because it's that Rx style, we're calling subscribe at the end, which is what's going to actually cause the sync to happen. So this call is now going to go into the backend module, and it's in the backend module where we make the request to app service, which is our retrofit interface. And so that's going to go to the server, hit the sync entities endpoint, which is where we get the request and the response back from the server. And since that code is being called from the backend module, we're back in the backend module now, and we can start using that response that we got and inserting those into the database. So this code is in the backend module, but in the DB module is where the actual SQL query lives that we're executing when we want to insert that payment. And so this is what that would look like. And that's pretty much the end of that call. We know at this point there's no more code that needs to be executed, but part of our paradigm on cache is that everything is an observable. So when this insert happens into the database, we use SQLDelight to then emit the payment back to anyone who might be subscribed to it. And so if we go up a layer into our backend module, there's this API for observable of a payment. And if anyone is subscribed to this, they're going to receive an event that a payment was just updated in the database. And of course, the presenter is the one who's subscribed to it because they care about this information and want to emit a view model to the app layer. And so that's what it's doing here. It's taking the payment, creating a view model, and emitting it to the view. And then the view is going to be the one who consumes that view model and then renders it to a screen. So if that payment was the one that updated with James, then it's going to propagate itself all the way from the DB layer up to the app layer, and that's how we're actually going to change that UI. So this is what the cache module dependency graph looks like. And everything I've been talking about so far actually could have been done in a single module. And so you might be wondering why we do this modularization of our app. I think the biggest reason and the most obvious one is that it's just going to improve your build times, mainly through incremental compilation. Through incremental compilation, essentially, you can make a change to, say, the DB module. And because the API module isn't a dependency of it, or I guess the API module doesn't depend on it in any way, it doesn't need to recompile when you change the DB module. So when you make that change, you can recompile, and it's going to run a lot faster. You're going to be able to get the installed build quicker. The other thing is that with these modules, you're able to define these really clear and concise APIs. And so you're setting sort of the stage that other modules are going to be able to interact with it. So let's suppose we now want to expose this new interface to interact with instruments. And an instrument in cache is anything that you can use to send and receive money. So it could be a debit card, credit card, ACH account. Those are all considered instruments. And so we're creating this new API to expose an instrument as an observable. And this interface already has a really clean contract to it. So it's very readable to anyone outside of that module. We know we're getting an observable, and you need to subscribe to it. That's what the check result does. In order to actually implement it, we have our reel. And so one of the big advantages here is now the dependencies are hidden from anyone who's consuming Instrument Manager. So in this case, we're depending on the app service, that's the API module, and the query wrapper, which is the DB module. That's how essentially a data access object that we're using to run our queries. And then we also pass in this scheduler so that from tests, we can make sure things are running on the same thread instead of on an IO scheduler where in production, that's what we would be doing. One thing I want to point out here is this internal keyword that you're adding to the class. The really handy thing about this is that now that this class is internal, you can't be accessing it from the presenter module, the app module, and you're essentially setting these bowling lane bumpers for anyone else who's going to be coding in your code base. You don't have to worry about them running code if they're in another module, and all of a sudden it becomes really clear where code needs to go. If you want to interact with the real instrument manager, you need to be in the backend module. And the same thing is true for, say, the query wrapper. If you're in the presenter module, you can't access the query wrapper. You can't run DB queries. And so you're probably writing the wrong code if you're trying to do DB logic in a presenter module. The way we're able to make this happen is with Dagger, so that's what the injection is doing there. So anyone who does want to reference an instrument manager from outside of the backend module, it's being given to them via Dagger by using constructor injection. And then probably the really nice part about this is that it's super easy to test. Now you have this very concise class, real instrument manager, and you can write a test for that, and you can use fakes for everything else. So you're only testing the real instrument manager here. We have a fake app service and a temporary database, which is going to be running in memory instead of on a device. And the thing I really love about the style of writing code is we now have a complete PR that we could submit. So instead of writing an entire feature as the backend, the presentation level, as well as the UI, you can instead just write the backend first, or just write the presenter first, or even just the UI, and that's its own PR on its own. So even for your peers who are going to be trying to review your code, this style of coding is going to make it a lot easier for them to interact with it as well. And that's in addition to making it a lot safer. Unfortunately, I have actually lied to you about what the cache dependency graph looks like. In reality, there's a configuration from DB onto the protos layer because we store some protos in the database. All of these solid lines are APIs, and so that means that that case I was talking about before, right, where presenters can't access the query wrapper, that's because the query wrapper is being implemented by backend. It's not being exposed by backend as an API. But in reality, in cache, all of these are APIs. And the reason this is the case is because we sort of started this journey into modularization about a year ago, and at the time, everything had access to each other. And so as we were splitting things out, we sort of had to keep them as APIs just to keep our code consistent. And over time, we're starting to switch it up. It's a lot worse than this even still. This is what the actual cache dependency graph looks like. As you can see, there's a lot more modules I didn't go into. The DB module is a mess. Pretty much everything depends on it, and it has a ton of dependencies. There's sample modules, which are things that we use to sort of test a minimized UI instead of the entire app. There's this module called thing. We don't have to talk about thing. So we're just going to pretend that cache looks like this. The next question you might be asking if you decide, yeah, I want to start modularizing is, how do you define these module boundaries? When do you start making module or put code into its own module? The way I like to think about this, and this is where the multi-platform is going to start to come in, is I like to think about modules in terms of their dependencies. And so it should be really obvious when you look at a module's dependencies exactly what it's going to do. The protos module just has a dependency on wire, and then implicitly protobufs, which is what wire is running on. And so if you look at this, wire is only being used from the protos module, and so that means this is the only thing that's going to be creating those models from protobufs. The API module is only going to be depending on RxJava, retrofit. So looking at this, you can tell that we're going to be exposing these observable interfaces from the server. The DB layer, it's going to be all of our SQLite libraries with SQLDelight, SQLbright. The backend layer is going to have Dagger. It has that dependency now on DB and API, so you know this is the module that's actually going to be working with both of them. And then I'm redeclaring RxJava here, and this is important because not only are we consuming the RxJava interface of the API module, we are also going to be exposing our new RxJava interfaces up to like the presenter level. And so this is very different from declaring it as an API. Like essentially any time that you have a public interface in your module that has, for example, RxJava, you need to declare it as a new API configuration. It's not enough just to API the retrofit or API module. So we're going to be doing the exact same thing again in the presenters level because it's exposing an observable of view models. And then it has things like analytics as well because it's doing all that business logic. But there's actually one more dependency I didn't mention that goes over this entire app, and that's the Android dependency. And you might not be thinking about it as a dependency, but really it acts the same sort of way. All of a sudden, in every single module, you're able to reference views, activities, fragments, context, all of these things that you probably don't want to be working with if you're just in the DB layer. And again, it's like these bowling lane bumpers. If you are able to access a context from the backend module, now all of a sudden it's easier to hold on to like a view and potentially leak it. You're giving yourself more access than you actually need to do. And so I think by limiting your dependencies, you're making it a lot easier to write code in a really large code base, which is what we're sort of running into on cache. Ideally, this is actually what it would look like, right? The app is the only thing that has to deal with the UI, with the platform. So it should be the only thing that has a dependency on Android. Now, the reason we can't do this right now is there's one more dependency in the protos module I didn't mention, which is that all of our protos are also parcelable. I mentioned we're storing protos in the DB. We're also storing protos in those instance states for views, and so they need to implement parcelable. And what this means is that our entire app, except for the DB module right now, because it doesn't have that dependency on protos, has to have that Android dependency. What about the DB module? Well, SQLite isn't a dependency we need to worry about. It's supported on nearly every single platform, so we can get rid of that. SQLDelight, it's generating JVM code, so just Java, so that's okay. It's still not platform agnostic because the JVM is a platform. And then SQLbright is working with RxJava, so again, we have that JVM dependency. So in order to actually make a purely platformless solution, this is where we need to solve it, which is why we're getting rid of them in favor of no, it's just SQLDelight 1.0. We're keeping the name because the way that you actually interact with the library is exactly the same. You're still writing these SQLite statements, and then they're compiling to code. The only difference now is that before we were sort of generating this Java code, now you're going to be generating Kotlin code, and specifically Kotlin multi-platform code. So currently, right now, this is in alpha stage. It's probably going to be getting into beta release candidate pretty soon because we're pretty confident in the API. And we're using this in production on cache. So the way that SQLDelight works, you write this SQLite file. It's a player.sq. So in this case, we're going to be writing an app for tennis. It probably would have been easier if I just continued with the cache example, but the US Open is happening right now, and I wanted to be topical. So we're talking about tennis today. So we're creating this new tennis app, and there are tennis players. They have ID, name, and country in this case. That's all the information we care about. And we're generating this Kotlin interface for that table. This is how SQLDelight works. Instead of going from Kotlin to SQL, we're going from SQL to Kotlin. And you can see it has an implementation, so that's going to be what's passed to you when you select from this table. SQLDelight also allows you to use custom types, but because the custom types have to be visible on your class path, if you're going to be writing multi-platform code, the custom types also need to be multi-platform, which is fine. So in this case, we're creating a tournament. Tournaments are held on a certain type of surface, and there's only 4 types of surfaces. So in this case, it's an enum. This is still all multi-platform because we're only really using primitives as well as multi-platform types that you are providing. The way these custom types work is now a table gets associated with an adapter, and an adapter needs to know how to go from every single custom type to a SQLite type. So in this case, we need to know how to go from that surface enum into text, which is what SQLite is storing. But now we're introducing a new thing. We're not just generating code in SQLDelight. There's also a runtime, which is this column adapter. So not only do we need to generate platform agnostic code, we also need to have a runtime that's platform agnostic. The column adapter is a really simple one because it's just an interface with 2 functions. Don't need to worry about that. But we also provide things like implementations of it. So here's like an enum column adapter that you get for free. So when you want to actually use enums in SQLite, you don't have to worry about writing your own column adapter. And then the way this works is when you want to create that query wrapper, the data access object for your SQLite, you just pass the adapter in. But there's one more thing that you have to pass in, which is the database. And this is going to be the actual driver who knows how to run SQLite commands. On Android, we have the SQLite Open Helper, or support SQLite Open Helper, and that's essentially the driver. But again, because we need to create a multi-platform runtime, we can't rely on that. We need to rely on something that's multi-platform. Right now, there isn't any multi-platform SQLite. So instead, what we do in SQLDelight is declare this very, very minimalistic view of what a SQL database looks like as an interface. And so once you get a connection from a SQL database, then you can start to compile statements, run the statements, get results back. But it's a very simple view, and it's so that we can make it platform agnostic. And of course, the implementation of the SQL database on Android is going to be that SQLite Open Helper. So in our little tennis app, this is what it looks like right now. We only have the one dependency, which is the DB module, and then the app module, which is going to have the UI and hook up into the actual database. The question is, where do we actually create that database driver? Because if we create it in the DB module, then now we're holding off any other modules or other platforms from accessing that database module. And the whole point of this talk is to sort of promote the idea of having your database layer live somewhere that's platform agnostic. The way that JetBrains suggests we handle this is via a new type of Gradle configuration, which is multi-platform projects. And this is how that looks in this dependency graph. Instead of depending directly on the DB module, we now depend on the platform-specific version of the DB module, which in this case is DB Android. The way you set this up is by declaring the DB module as multi-platform. So this is common code, so you apply the common Gradle plugin, common Gradle multi-platform plugin. By doing this, you gain some superpowers, namely the expect keyword. And when you say something is expected, that means a platform needs to provide the actualization of that. So in this case, remember, we need to figure out how to create that database driver on different platforms. So in the common module, we're expecting a platform to give us the actual driver, so we expect it. In the Android implementation of that multi-platform module, this time we're saying that we are a Kotlin Platform Android plugin, and that we are expected by the DB module. And this is how we set up that multi-platform configuration in Kotlin. And so from one of these platform implementations, we now have the actual keyword, which is the counterpart to expect. And we can provide this now Android driver to the common code. And it's based off of context, and it's based off of that support SQLite Open Helper. SQLDelight also has some extension functions to really easily help create the query wrapper. So that's what this is doing here. The query wrapper is helping you create that implementation of the SQL database interface. But under the hood, it's using SQLite Open Helper. Now from the common code, we can start to actually work with these things that we expected. So in order to create the data access object query wrapper, we can depend on that database factory, which was an expected class. And then from our actual app module, we can start working with common code that we wrote. So here we create the query wrapper, and then we can start using it. So in this case, we're inserting Novak Djokovic into the database. You might notice I've left a lot of blank space at the bottom left here. So new challenger approaching, the iOS app is now starting to use this code. Similar to the DB Android module, we now have the DB Native module. And what it needs to do is provide that implementation of the database factory, provide a driver in the native world. Luckily, Kevin has done this and has published NARC, which is a SQLite driver for Kotlin Native, as well as some runtimes for SQLDelight for Kotlin Native. And what this means is now we have a native driver for SQLDelight that we can use from native. And this is how that looks. So we're creating the actualization of that database factory, and it's using default system context, iOS native open helper factory, which are two of these classes that you can find in NARC. And that's how we're able to use SQLDelight from iOS. So very similar to what we were doing in Android, we can create that data access object, and then we can start using it to insert Novak Djokovic into the database. There are a few little quirks here that are different from when you're using it from Android. The thing about it is, like with Kotlin multi-platform, when you're on Android, you're still working with just Kotlin, so there's no actual differences from what we're used to. But when you're using it from iOS, it's going to be a little bit different because Kotlin is in a supported language of like the environment. So things like the DB prefix on all of the classes that you define in Kotlin, that's something you can change, but it's going to be stuck around. The DB query wrapper helper, that's actually the companion object for the query wrapper, but companion objects aren't a thing in Swift, so instead they get actually rasterized as their own type. We named it helper explicitly. Okay, so now the question is, why are we doing all of this work? It's a lot of extra overhead just so that iOS can potentially use it. The answer is so that we can start writing more code in the common DB module. So that insert statement lived inside of the DB module. That's where we were writing SQLite. We can also start using the query wrapper data access object inside of the DB module as well. So those inserts of Novak Djokovic, we can instead do that in the common module, and we don't need to duplicate that code across Android and iOS. I'm also going to start introducing some more types here that we have inside of the database. So here we have the match, which happens at a tournament between two players and there's a winner. And we can enforce constraints here. So we're making sure that our data is consistent both across Android and iOS, where the winner has to be one of the two players can't be the same. So we seed that data as well. Of course, if you're writing an actual app, this would be coming from the server, not hard-coded, but the same idea is there, you could use it. And then you can start doing more business logic in the DB module as well. So here we're computing the actual head-to-head between two players and figuring out who has more wins. The way this is going to work behind the scenes is SQLDelight is going to do the exact same thing it was doing for just Android. It's taking that SQ statement or SQ file with SQLite statements in it and starting to generate interfaces as well as APIs for you to interact with the database. So each projection is going to get its own interface. The head-to-head projection looks like this. And then there's going to be a way to actually run that query on the database. This is the API for that. As well as if you don't want to use the projection interface we generate, then you can pass in your own Lambda, which you can use your own types if you want to. This is important. This will come back in a second. But now I've introduced a new runtime type, the query type. And this is a really important one because this is the API you're going to be interacting with when you're actually running the code. So let's take a closer look at that. It has a few methods on it for actually executing the statement. What this means is that a query, when it's returned to you, it hasn't actually been run. It's just the information that it needs to run a query. And it's not until you actually run execute on this that it's going to run the query and then return a type-safe object back to you, either like list of the row itself, or row or null. There's also an execute method which returns essentially a cursor, but I didn't include it here. But what I want to point out is now there's this listener interface. And if you remember back to how I was describing cache, we're communicating entirely in observables. And so really it would be nice if queries had this observable interface instead of these blocking execute statements and then a listener on top of them. In order to do that, the best way is for it to live on the query. But if we do that, then we're blocking out everyone else because now we've reintroduced that RxJava dependency into the query layer, and that runtime exists in the common module. So we can't put it there. Luckily, Kotlin comes to save us with extension functions. Extension functions essentially give us the tools to make these APIs on top of types, but in a separate dependency. So now this is an RxJava 2 extensions dependency that is separate from the SQLDelight runtime. And it's going to have some helper methods on it too that can help you with RxJava if you just want to like map an observable of a query to an observable of the actual item. And what this means is that you can depend on the RxJava extensions just from your app module, and now you're not leaking that RxJava dependency over the entire dependency graph, which is huge because you don't want to block out iOS from using it. So now we have the interface we want. We're able to actually expose observables of queries instead of just the queries themselves, which is great. We're able to find the head-to-head between Federer and Nadal. iOS is going to have the same sort of restrictions. It's not just Android where we want observables. iOS is going to have their own things that they want. Talking to the iOS team at Cache, one of the things they really, really care about is value types. And value types are something that's coming to Kotlin, but not here yet. And so there's actually no way for Kotlin code via Kotlin Native to generate a value type. The reason this is so important is they're a super lightweight, similar to data classes in a way where you can like easily copy them around. And on Swift especially, and in the LLVM bitcode that's compiled from a struct on Swift, it's copy on write. And what that means is that you're passing by value instead of passing by reference. You don't have to dereference the type, but it's the same type being passed around everywhere instead of copying it all the time. And it's only when you actually go to change one of these values that you get a new version of that type. So it's a really, really powerful feature. And especially for something like your data layer where you're going to be passing these projections all around the app, it's really important for it to be lightweight. If you remember back, I was saying that you could pass a lambda to a query that you're running against a SQLite database if you want to use a custom type. So this is going to work for iOS, so we can get those structs that we want instead of getting the data classes that SQLDelight generates. But in order to do that, you have to write this method that knows how to go from the projection into your type, and then you're going to actually pass it into the query when you're running it from Swift code. And this is what that looks like. But there's another big problem here, which is this enforced downcast. Unfortunately, Kotlin Native right now doesn't support generics. And so if you want to be able to support custom types, that means you need to have generics in your API, but Kotlin doesn't support generics, and so if you ever change the type, this code is now going to fail at runtime, which isn't great. Kotlin Native is still early on, so I'm optimistic that this can actually be handled. Of course, Swift handles generics as well as Objective-C, so I'm confident that they could be helping us handle this. But there are other things that we could be doing from the SQLDelight side as well. We're generating that Kotlin code. There's no reason we couldn't also generate Objective-C header files or Swift modules that give you structs instead of data classes, or that make sure everything is genericized properly. So hopefully this gets fixed. So the other thing I want to address is why this is worth doing, or why this is worth selling to your iOS team. I think the really big thing is that you get this like shared expertise around the DB layer. If you have the same DB layer and you have any bugs in it, then all of a sudden it's up to everyone to help solve it together. And if you have people who are like particularly astute with SQLite, then they can help out even if they're on the iOS team, or if they're just particularly familiar with that feature. Documentation is a really big one. This essentially becomes something that's similar to an open source library, because now you're not the only consumer of this module. You need to make sure that the other consumers know what's going on and that the APIs are clean. So it forces you into this like mode where you have to document things really clearly and you have to have those clean APIs. But there are bads to it as well. I foresee that maintenance is going to be a big problem. Because the module is going to be written entirely in Kotlin, I wouldn't be surprised if ownership over it is probably going to land mostly on the Android team, just because they're the ones who are familiar with Kotlin. Thankfully, Swift and Kotlin are similar enough that I could see it being really easy for someone who knows Swift to go in and make changes, but I still think that's a problem that could come up. And the same thing is true of code review. When you're writing new code in the module, you would want iOS engineers to also be reviewing that code. So now you're forcing them to know Kotlin syntax. It's just like an extra burden you're adding on. I do think, though, that there's a really big pro to all of this, which is that you get testing across both platforms for the cost of one. In this case, we're just checking to see that our head-to-head query actually works. What's so amazing about multi-platform is that this test isn't just running against common code. It's going to be running against every single platform implementation of the common code. And so this test is going to run twice, once for Android and once for native. And then that way you know when you're making any changes that both native and Android are going to react properly. So I think this is a huge win. Some of the other things that I want to touch on are like things that we're doing in SQLDelight that would be beneficial to both platforms in this upcoming release. The big one is that we're starting to handle migrations now. So before, this was entirely up to you and there was no type-safe way to do it. Now, when you apply the SQLDelight Gradle plugin, you get these two new tasks, generating a schema and verifying your migrations. So when you first apply the plugin, you can generate a schema. Once you do that, if you go back to one of your tables and you make a modification to it, so in this case, we're adding a ranking for each player, when you run the verify task, it's going to fail and tell you exactly what went wrong. So in this case, we're missing that rankings column on the players table. All you need to do now is write a migration file for that specific version. So in this case, you're upgrading from version 1, so it's 1.sqm, which is for migrations. And we put that alter table statement. And now, once you have this in your code base, the verify task will run successfully. We also have some shorthands that we're introducing into the system. So essentially, we try in SQLDelight to make it so that you're writing only ever SQLite. But there are times when it would be really handy to have these shorthands that aren't available just to SQLite. So one example is if you're inserting into a table, you might not want to do column by column. Instead, what you would want to do is insert an entire object on its own. So we've made this shorthand where you can just use a single question mark after values instead of question marks for each column. As well as for things like set contains. If you want to see if the surface of a tournament is in some set of enums, then you can use the same sort of shorthand where you just have a single parameter, and then we let you pass in a collection. Another thing we're introducing is this in-memory SQLite driver for JDBC. So from testing, for example, if you don't want to be running your tests from an actual device or using RoboElectric, then there's this JDBC driver that you can run in memory to run your tests. OK, so what does this all mean for cache? Not a whole lot. If we make the DB module multi-platform, the dependency tree doesn't actually change at all. We still have the exact same class path as we did before. It's just this extra module which is providing an Android driver for now the common DB module. What this means, though, is that the iOS team, if they ever wanted to use this code, can. As long as they provide a driver in native, or we provide it for them, then they can start to take advantage of that DB module. But there's even more to it than just that. If we go back to our protos module that we had before and look at the dependencies we had, if you were just at the OKIO talk that was just happening, you know that OKIO, just 2.0 was released. They're starting to do multi-platform. That's the only platform dependency of Wire. And so with that release, we don't actually have to worry about Wire being platform specific. Protobufs themselves are already platform agnostic. We don't need to worry about that. Parcelable, the strategy we're taking here is using the parcelize plugin by Kotlin. And what this means is that you can provide a parceler for an object that isn't the object itself. So instead of implementing parcelable, you can instead provide a parceler for any of your wire messages. And then that way, the dependency of parcelable can leave the protos module. So now we have no more platform-specific dependencies of the protos module, which means we can start to open up that module as well for multi-platform. Once we do the same for retrofit, which is another thing they're thinking about doing after OKIO, we can start to bring the API module up. You can do the same for backend, for presenters, for view models. All of these things that don't have a platform-specific dependency can become platform agnostic. And once you do that, they can become multi-platform. And it's possible for iOS to use this, although I don't foresee anytime soon our iOS team adopting our presenters or backend modules. The idea is that writing this platform agnostic code is still going to be a win even if no one else is using it. And then it's an even bigger win if your iOS team is going to start using it, or web team for that matter. Speaking of web, I want to talk really briefly about SDK Search, which is a multi-platform open source app that Jake Wharton has built. This is the project dependencies graph for SDK Search. This is what the Android dependency graph looks like. So at the root, it has that front-end Android project. There's also the multi-platform specific part of the dependency tree. And I want to point this out because if you look on the left there, there's Search Presenter, which depends on sync, which then has a dependency on API, and then it has a dependency on store. And this is pretty much exactly the same as that idealized cache dependency tree I was pointing to earlier. And if you know Jake's employment history, that shouldn't really be a surprise. But yeah, this is sort of the idealized like multi-platform world that we want to get to. And then in addition to having that Android implementation, they have on SDK Search the Chrome extension as well for it. And that's it. That's sort of where I see cache going, as well as how I see multi-platform fitting into our app. Hopefully this was a useful exploration of what dependency management looks like in a platformless world, and how it could be beneficial to you as well. Thanks for watching.